Sorry, starting the notes a little late. So it's when you go to interpret a derivative, if you write it this way, then it's really just staring you in the face. D is more like the calculus notation for delta, small change. And so change in position over change in time. What is change in position with time? Velocity. Okay, now in this case, there's a physics interpretation to it. Sometimes it won't have a physics connection. They're not all going to be physics problems, but in this case, it's physics. P prime at t is the velocity of the student. It says using correct units. So it's the velocity of the student in what? In miles per minute. In miles per minute. The velocity of the student in miles per minute. Don't assume it's still meters or miles per hour. Go with what they give you, miles per minute. You with me so far? All right. Oh, darn it. I just did it. It's the, we'll come back to that later. Okay. That is going to be more of a general, I wish I would have put that somewhere else. That's all right. Skip down to B, please. Now this is asking you to interpret a derivative at a certain point in time. And it words a little differently. P prime at 8, interpret your results. First, calculate P prime at 8. Please get out your calculator, and you'll need it today. Calculate P prime at 8, 1/100th. Yep. Oh, thanks, pal. 100th times 64 minus 12 100ths times 8 plus 35 100ths. Did you get 3 100ths? Yes. Okay, cool. All right, then. Report your result. It's best to attach units both in your answer and in your explanation. So what are the units on that? It's miles per minute. Okay, miles per minute. Now when you're interpreting that, a numerical derivative using this basic format, at first say when. At time equal 8. Okay, you don't just start saying it's the velocity, but you start by saying it's at a certain point. At time equal 8, the velocity of the student is, and scratch that, that's more of a problem that's going to come later. And the velocity of the student is 3 100ths miles per minute. Cool? Okay. Let's get a little more, actually you know what, I don't, in the interest of time, do you feel like this is going okay? Do we need to do the you try? Okay. Let's go to the harder ones. The physics ones I feel like you're probably going to be fine on. It's the ones that are not physicsy that are going to be a little harder. All right. So not everything is a physics kind of motion problem. You can have rates of change in a lot of different things. So the amount of water in a lake at time t is given by that big function. From time 0 to time 10 days, both through rain and through evaporation, the volume of the water is changing. So would you start by getting that function in your calculator, please? 5,000 t plus 10,000 sine of t plus 10,000. Make sure you calculate it in radians. Make a difference. I imagine the scale of those numbers is going to make for a pretty lousy window. So we'll want to adjust our window. The Inspire does a pretty nice job of zoom fit, but you can't always rely on that. I would try zoom fit first and then see if you're seeing what you want to see. So in this case, window, and menu, window, zoom fits A. It doesn't really know specifically how much of the curve you want to see, so it's going to take a guess. And my zoom fit shows 0 to 10, so I feel like that graph is pretty good. Is that what your graph looks like? Yes? No. Okay. If your graph is, thank you. Gosh, was that so hard? It's just one syllable word. All right. Now then, this is the amount of water at a given time. So if I were to find and interpret A prime, let's start by finding A prime at any t. A prime, what is the derivative? What's the derivative of 5,000 t? 5,000. What's the derivative of 10,000 sine t? 10,000 cosine t. And what's the derivative of 10,000? 0. Okay, cool. So there's the derivative. Now, let's talk about how this is, besides A prime, I could also think of it as dA dt. Change in A with change in t. Change in amount of water with time. This is where you're not going to be talking velocity anymore. The derivative of position is velocity, but there's no position velocity component to this. So it should be worded more like actually I should start with A prime of t is the rate at which the amount of water changes in, and then the units. A prime at t is changing water over time. It's the rate at which the amount of water changes in, and what are the units? dA dt. A's units are liters, and t's units are days. So it's the rate of change in the amount of water, or the rate at which the amount of water is changing in liters per day. Cool? Would you find then A prime at 3, and let's talk about the interpretation of that. A prime at 3. Now you could do that one of two ways. You could slap that whole thing in your calculator, have your calculator do the derivative, or you could just take your derivative and put 3 into that. Either way, you should get the same answer. Plus 10 cosine of 3. I think I need parentheses around that. I'm getting negative, I'm getting something, negative 4,899.924. How about you, or 925? Is that what you're getting? Okay, so start by reporting your answer. A prime at 3 with 3 or more decimals rounded to truncated is negative 4,899.924, 925, rounded or truncated, or you can give me more than 3 decimals. Okay. All right. Now then, interpreting the answer. When you're interpreting the answer, it's not like the previous interpretation. That's the interpretation of just general A prime. You're interpreting that number. And so your number here should be an explanation. Start by with the time. At time equal 3. What are the units on 3? Anytime you still throw a number in there, you should have units on it. Time equal 3 days. The amount of, now, what you're talking about, the amount of water in the lake. The next thing you do is say, what is changing? Is, the The next part of it is you don't just say change. They expect you to interpret the signs of the change. Now in this case, the derivative is negative. If the derivative is negative, the function is decreasing, and you have to say that. You have to communicate, hey, I know that it's changed, but specifically I know how to interpret the sign. The amount of water is decreasing at a rate of is always there. And then finally, interpreting your answer. Negative 4,899.924 with units. What are the units? Liters per day. At that point in time, the water in the lake is decreasing at a rate of almost 5,000 liters per day. It's probably at one of those. Okay, let's think about it. On the graph then, where's that talking about? Here's time 3. Does that make sense that the amount of water is decreasing? Well, yeah, the tangent slope's negative there. So yeah, it does feel like it's decreasing. We good? You with me? Okay. What about A of 3? A of 3 is not going to involve the derivative. So A of 3 is just plugging in to the equation. Calculate A of 3, please. So we're not using the derivative now. We're using the original function. Whoa, baby. I hope I did that right. Did you get 26,411-ish? Yeah. Okay, cool. Okay, so record to 3, 26,411.200. What are the units on that number? Liters. Now, is this a rate or what is A? Use the answer. Use the guide. Use the amount of water in a table at time t is. So is it liters, days, liters per day? What? Liters. It's liters. Okay, it's just in liters. All right. If you want a word or abbreviation is acceptable. Interpret your answer. What does it mean? First, refer to the time. At day 3, or on day 3, whatever you like. At day 3, or time equal 3 days, the what? The amount of water in the lake is 26,411.200 liters. A gives the amount of water. Now, that's going to make things harder because you're going to have, in a problem, a calculus problem, you're going to have at least 2 functions working, the function and the derivative, and later the second derivative. So you're going to have to get straight in your mind which communicates what, or what each one is doing. The derivative is a rate. The first function is usually an amount. All right. What about D? Is the amount of water increasing or decreasing at time 2? Justify your answer. I'll give you a second to think about that. Try it on your own with your math amigos, and we will go over it in a minute. You're required to give evidence for your conclusion. In calculus, looking at the graph is nice, but that's not justification. Ready or not a minute? Ready. Okay. Think calculus. How do you tell if something's increasing or decreasing? If its derivative is positive or negative. And that is very much how you justify it. Okay. So in this case, you should have been either using the derivative you calculated by hand or having the calculator do the derivative for you, whatever. But your value should be at 2, 838.531. Is that what your derivative at 2 is? Did you calculate the derivative at 2? Okay? Now, saying the answer, you would first communicate what you did. A prime at 2 is 838.5316. Again, I will constantly write 4 decimals. That's just my habit. You only have to give 3, and it can either be rounded or truncated, so you could have 0.531 or 0.532. I'm going to throw units on that just because I'm an overachiever. What are the units on A prime, which is the ADT? Change in amount with time, that's liters per day. Now let's answer the question. Is the amount increasing or decreasing at time 2 days? Increasing. Why? Yeah, okay, so you would have to say the amount is increasing at time equal 2 days because A prime at 2 is positive or greater than 0. Okay? It would not, this is a common mistake usually with the BC students, they feel like it's so obvious. It's not enough to say it's increasing, you figure out why. You have to communicate, hey, it's because this is positive, that's why it's increasing. You with me? The derivative is positive. All right, are we good so far? Cool. Let's move along. All right. 2 ways. This is where things get a little hairier when you get to integration. Even hairier, but we've got competing rates problems. Rate in, rate out. During the time interval 0 to 18 hours, the number of people entering the fare is E of t, while the number of people leaving the fare is L of t. Would you please go to your calculator and put those two functions in F1 and F2? Okay, what are my functions? Please, I would strongly recommend that on your paper you write below each one where you put which one. So below E, I would write F1. Below L, I'd write F2, so you know which one's where. Okay? The square root of x plus 1. Ah, shucks. Oh, what the heck is going on? The square root. X plus 1. I think that's right. Wow, that's really small. Oh, my window's still set to the previous problem. No wonder it's so small. Okay, I'm going to set my window back to a standard window until I know what's going on. That's also terrible. I guess I'll work that out in a second. Give me a minute. All right, e to the, does that say t minus 1.2 or 12? 12? Thank you. All right, how does Zoom Fit go? Does it work pretty well or not so much? Okay, so for 0 to 18 hours, I'm going to change my window to 0 to 18. I don't know about the y's. The y's I don't need negatives for. Okay, maybe something like that. All right, how are we doing? You have something like that? You might change the window. If they give you Windows 0 to 18, you should use it. You don't want to look beyond the bounds of where they ask. All right, now then, let's just talk using our common sense. The blue line, for me anyway, the blue line represents the E function, which is enter. The red line is the leave function, which is leave. In terms of the whole fair, or the number of people at the fair, when the blue line is above the red line, what's going to be happening? Okay. Actually, if enter is more than leave, then the number of people will be increasing, and when leaving is greater, the number of people will be less. So we'll talk about that in a second, but let's go to A. Find E prime at 7 and interpret your answer in the context of the problem. Would you do that, please? And then we'll confirm. This is my F1. This is my F2. F1 prime at 7. Is this 2 times? 7. First derivative of F1 x. Check your value first. Do we agree with 5.9375? Yes? No? E prime at 7 is 5.9375? Okay, cool. Now let's talk interpreting. E prime in Leibniz notation is dE dt. So that's change in the number of people who E is enter with time. So talk to me. What does this mean? Interpret it. At first make reference to the time. At time equal 7 with units, hours. The rate at which people are leaving, or people are, now this one you're not going to actually interpret, or not leaving, entering, excuse me. People are entering at a rate of 5.9375 what units? People per hour. Roughly 6 people are coming per hour. 6 people are entering per hour at 7 hours. You with me? All right? Would you find and interpret E prime at 18 minus L prime at 18? That one's a little harder. Calculation and what it means. Okay. When I go to enter this, do I need to do this derivative calculation separately, or in that one parentheses, can I put f1 of x minus f2 of x? Can I do that? Yeah, why is that allowed? Because the derivative of a difference, isn't that just the same as the separate derivatives, yeah? So I could do that and call this f1 of x minus f2 of x all at once, and that would be good to go. I get negative 400.928. How about you? I'm having trouble reading you people. Is this about what you got? Negative 400.928? Okay. Now the interpretation of this is going to take a little more thinking. E prime, it's the rate at which people enter. L prime is the rate at which people leave. And so the difference between the two is what? If I take the enter rate, take away the leave rate, isn't that? It's really the net change, right? I like net, but we'll probably call it the overall rate of change. Now, because that's negative, the amount of people is increasing or decreasing? Decreasing, all right, because that's negative. So let's go here. At time equal 18 hours, the total number of people in the fair, or the number of people in the fair is, now here's where we need to be careful to interpret the sign, is increasing or decreasing, not just changing, decreasing at a rate of 400.928 units people per hour. Okay. At 18, more people are leaving than coming, and so the number of people is decreasing. Cool? Or how would we address C? Is the number of people at the fair increasing or decreasing at time 17? Let's talk about it. First of all, do I need to talk about the number of people, compare the number of people who have entered or leave, or do I not need to compare the rates of change in the enter and leave? The rates of change. And so I need to do one of two things. I need to either do enter at 17 minus leave at 17 and interpret the sign, or I could just compare enter rate at 17 versus the leave rate at 17 and just say which is bigger. Now either one will work, and either one is fine justification on the AP test. You could find each and say, see, the enter rate is greater than the leave rate, so the number of people should be growing. Or you could just say the net rate is positive or negative, and that would do it. In the interest of time, I'm going to leave it at that, but do you understand either one on that? Could you do one of those on your own, please? Yes? Okay. It's 18 minus L at 18. Would you do that, please? And then we'll move along to the last idea. E at 18 minus L at 18, round to the nearest whole number, interpret your answer. Enter is... roughly negative 264. Do you agree with the value? Okay. Is this a comparison of the rates or amounts? Amounts. So the enter minus the leave, the total number of people who have entered by time 18 versus the total number of people who have left by time 18 is negative 264. Interpret that. And by time equal 18 hours, what has happened? Or at time, whatever you like. 264 more people have button. Have left, then enter. And the difference between how many is left and enter is 264. Left is bigger, so it must have, which is why it's negative, so more people left. Okay? All right. Last idea is totally different, switching gears. More of a analytical derivative technique kind of problem. So it is very often the case that in physics especially, you want what's called a normal line. If you have a force here that works this way, sometimes you want a perpendicular force. That then is the normal. The normal is, I don't know why I'm doing this over here, the normal is tangent, or is perpendicular to the tangent. So when they ask you to find a normal line, it'll be a ton like a tangent line question. To find the equation of a normal line, do almost exactly the same work as the tangent line. You first find the point, then you find the slope, then you write the equation in point slope. The only difference is for the slope you use the opposite reciprocal of the tangent slope to get the perpendicular, which would be then the opposite reciprocal of the derivative. That's where we get the tangent slope, yeah? So let's do it for practice. If I asked you to find the equation of the normal line to 3 sine squared at x equals pi over 6, let's start with a point. We know x equals pi over 6. They give that to us. The y is f at pi over 6. That's 3 sine of pi over 6. The sine of pi over 6 needs to be found, then squared. What's sine of pi over 6? One half. So that's 3 times a half squared. Therefore, the point is pi over 6, 3/4. That's the point on the curve at which I'm drawing a tangent slope. The curve kind of looks like this, and I am right here. Okay, the slope. Let's start by the derivative. You're going to first find the tangent slope. Then I'll deal with the normal, the perpendicular part. So the derivative, the slope, or f prime, at pi over 6. First, give me the derivative of 3 sine quantity squared. Is that a product rule or chain rule? Chain rule. Okay, so the derivative of the outside is the derivative of 3 blank squared. What's the derivative of 3 blank squared? 6 blank to the 1, and the inside still stays the same. So what's inside? Sine of x. Times the derivative of the inside, which is the derivative of sine, so times cosine. Then say at pi over 6, or I'm about to evaluate that, at pi over 6. 6 sine pi over 6. What's sine of pi over 6? 1/2. And what's cosine of pi over 6? Root 3 over 2. Therefore, our tangent slope is something like 3 root 3 over 2 if I reduce it. Therefore, what's the normal slope, which is the perpendicular? Opposite reciprocal. What is it? You get 2 over 3 root 3. You'll be happy to know that in calculus, I couldn't give a rip if there's a root in the denominator, right? It doesn't matter. I don't care. I don't need to rationalize it. I don't care. So leave it like that. Now write your equation. Slope, point, slope, the equation in point slope form is y minus. There's the point. So y minus 3/4 equals the slope, -2/3√3, the reciprocal slope, times x minus pi/6. You can see why point slope is where it's at. You definitely don't want to go about finding the plus b in point slope or slope-intercept form. That would be so tedious. In calculus, point slope form is just so much less work. All right, you with me? Okay, cool. The interpreting will take practice, and we'll practice it on AP test soon, but we have to build up a little more first. Okay, the homework from last night, how did it go? Great or disastrous? Or I didn't do it, and I stink? 11 was confusing. Okay, I'm going to go through a few based on what I've had the most questions on. So let's talk about, let's go to 5 first, shall we? I think that's the one I had a lot of questions on. Okay, if you had trouble with 5, let's go there. Sine up to pi/2 looks like that. What are the reference angles between 0 and pi/2? Pi/6, pi/4, and pi/3. Now, if you were to find the rectangles here, 4 right-hand rectangles of unequal subdivisions, if they're right-hand, then the first rectangle, wouldn't it be at pi/6? The next one would be a pi/4, then pi/3, then pi/2, yeah? Are you with me? All right, the hard part for people was when you go to set up the rectangles, base 1, height 1, through base 4, height 4, all that pi stuff on the denominator stinks. Now, if that's the case, I'd recommend doing a little more and getting a little more in detail. If you look at each of these, there's a common denominator, pi/12, things will go much better. This, pi/6 is 2 pi/12, yeah? And pi/4 is 3 pi/12. And pi/3 is 4 pi/12, and pi/2 is 6 pi/12. With those, it's a lot easier to find the base. I'm going to do, I think it'll go easier if I find each base first. What's the first base? 2 pi/12 or pi/6. Either one is fine. Times the height, I'll find it in a minute. What's the next base? From 2 to 3 pi/12 is pi/12. Times the height, I'll find it in a minute. How far is it from 3 pi/12 to 4 pi/12? That's a pi/12. I'll find the height in a minute. And the last base is from 4 pi/12 to 6 pi/12. That's 2 pi/12. I'll find the height in a minute. Now, the first height is f at the right side. So now this time I'm going to go back to the reference angles. F at pi/6. The next height, height 2, is f at pi/4. The third height is f at pi/3. And the last height is f at pi/2. That's from there, that's where I got my answer. Now the good news is for 6, it's going to be a lot of the same work. For 6, I know it's cosine, but the bases and the reference angles, they're going to all be the same. It's going to be, again, the first base is 2 pi/12 times the height plus pi/12 times the height plus pi/12 times the height plus 2 pi/12 times the height. And in fact, because it's right rectangles, it's going to be the same reference angles, f at pi/6, f at pi/4, f at pi/3, and f at pi over 2, the trig will all be different, obviously, sine instead of cosine. All right, does that get you going? Okay. I don't know if I included my over-underestimate statements. Did the over-underestimate statements go okay? Okay. Please don't say because the rectangles are below the curve. That is great. I understand. It doesn't wash on the AP. It has to be because I'm using right-hand rectangles on an increasing function. Because I'm using left-hand rectangles on a decreasing. It's got to be said that way. Again, it goes to the 300,000 exams being graded. It's got to be said in a kind of a blueprint way. You with me? All right. Did this go okay? I don't remember getting a lot of questions on this. In this problem, the only gotcha was that you had to use this to say increasing. Because f prime is positive, that implies f is increasing. That's how you do the over-underestimate justification. Okay? This guy. This is a big idea of calculus that I don't know if I succeeded in getting this across. Okay? When you go to graph this, oops. 1, 2, 3, 4, 5. I want to focus on part B. When you do the area here, and you say each of these base 1 height ones, or each of these, you could have factored out a base and that's fine, but I'm going to focus on that units here. In this first base, what's the base with units? This is time in seconds. So it's 1 second, right? The height, it's right-hand rectangles. So the right-hand rectangle would be using the velocity at 1. You tracking? What is the velocity at time 1? 1/5. What are the units on velocity? Meters per second. All right, now this is the point of all this rectangle stuff. That area is not just some generic rectangle area. Who gives a rip? When I multiply and find that area represents how many meters this person went in 1 second. That area represents distance or displacement, distance traveled on each little subinterval. So it looks like in that first second he went about 1 meter. Now it's probably a little less because that rectangle is overestimated. So he probably didn't go a full meter, he probably went a little less than a full meter, or 1/5 of a meter, sorry. The next, when I say it's another 1 second interval, and I look at height 2, that's height 2 is velocity at 2, yeah? Velocity at 2 is 8/5 meters per second. So when I do that second rectangle here, that's not just some worthless rectangle. That represents or is estimating how far he went or she went and the car went. In the second, it went about 1 1/5 meters. The total then of all these is a representation of how far the car went over 5 seconds. Area represents change, total change. And you take a rate times the time to get change.
Good morning, Dublin Jaguars. Please rise for the Pledge of Allegiance. Please begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So I'm going to put these interpretations up real quick.
National Junior Honor Society will be in the cafeteria on Friday, 37th hour. Please identify the cafeteria and report to the cafeteria and let Mr. Copeland go to the conference.
Students, come see the Dublin Performing Arts production of Thornton Wilder's Art Announcement Thursday, Friday, and Saturday at 7 p.m. walk with you through that heat. Tell us the story and come for your amazing theater stack.
Today in California, all of the colleges will be here to Hillsdale College, Grand Canyon University, and Trinity University. Remember, please rest the very important steps to the college of your choice. All students are welcome to attend, not just juniors and seniors.
That area under that term would be change in population over 10 years.
The Fulton University, University of Illinois, Westmont College, Concordia University, Case Western Reserve University, Washington University, St. Louis, St. Mary's College of Maryland, Stonehill College, Williams College, Yale University, Caltech, and Oregon Institute of Technology.
Tomorrow is the Lakewood High School out-of-state college fair at 6:30 p.m. If interested, a financial aid presentation is at 5:15 and 6 p.m. prior to the fair.
Join the football team for a fundraiser event at Tuck Tuck High Grove today. Offers good all day lunch and dinner at all 3 Tuck Tuck locations. Lakewood, KC, and Westminster. Just mention Devlin's football at the register and 100% of your purchase will go to the team.
Today during this hour, there will be a girls' swimming satisfaction in the auditorium. Most of the returning athletes, please come to learn more about.
Or 7 a.m. to 9 a.m. would be good here too, preferable actually. Hi.
Please come to Overland at Kid Lane W this Friday from 6 to 10 p.m. to help raise money for the volleyball team.
39 extra practice or the actual practice?
For the cafeteria during
You
the
left
hour for
or
11
lost?
number 2.
my name on it.
Congrats to the girls softball team for beating Stanley Lake 12-2. What a great day for the seniors as Jake Hewitt and Isabella Perigo both had 3 hits, and junior Peyton Falcon had 3 home runs to seal the victory. Great job, ladies, and good luck at Evergreen tonight.
Congratulations to the cross-country freshmen and sophomore girls who had a great performance yesterday at the Colorado Invitational. Beginning 4th place against the big freshman Eliana Thompson crushed her own personal best, making it onto the DHS cross-country board. This means she has run one of the top 7 times in the history of our program. Wish to keep up as they race on the same course this Friday. That's all your announcements. Have a great day.
Okay, now this, if you're just kind of getting it, that's fine. It's gonna be a big idea through the whole year, so it's just an introduction. But area, when you take a rate on the y-axis times an amount of time on the x-axis, when you do that in a unit multiplier kind of way, the rate drops out and you'll actually get change or amount of change accumulation. So for example, in C, you're talking about the area is the number of problems the student did from time equal 12 minutes to time equal 20 minutes. What's going to be different than from physics is in junior physics, you did constant uniform motion. The rate always stayed the same. 5 meters per second for 3 seconds is 15 meters. Calculus deals with light, which is your rate doesn't stay the same. I mean, you don't take off of a light and your rate's the same the whole time. Your rate's constantly changing. So calculus makes infinitely many calculations of rate times and adds them in the fundamental theorem of calculus. So it's just okay? But for now, area is changed. If you're totally just blown away, then good, that's calculus. But come in 7th hour, and I will help you. Yeah, have a good day.